Hello friends, welcome to this practical course on Etabs. In this lecture I will explain you what is earthquake load, what are the different methods of earthquake analysis or the seismic analysis, and in what conditions we are going to use these different methods. Then we are going to apply earthquake loads for our G+7 floors building in Etabs. So in short I will be covering seismic analysis right from basics so that all the beginners can also learn this easily. A special request to just be with me till the end. Let's get started. So in order to perform the seismic analysis, there are two different methods. First is the static analysis method and the next one is the dynamic analysis method. So what is the meaning of static analysis is that whatever the earthquake loads that we will apply onto our structure will be static. That means they will not vary with time. However, in the dynamic analysis, the loads will vary with time. In the static analysis, we have two different methods, that is linear and non-linear methods, and again in the dynamic analysis we have linear and non-linear methods as well. So here the meaning of linear method is that whatever the properties of concrete that we are considering in our structure are considered up to only linear range. However, the concrete will have some strength beyond its linear range in the non-linear range. So in the non-linear analysis we will consider the non-linear behavior of the concrete. However, in the linear analysis we will not consider the non-linear properties of the concrete. The example of linear static analysis method is the equivalent static method. Similarly, the example of non-linear static analysis method is pushover analysis. Example of linear dynamic analysis method is response spectrum method, and example of non-linear dynamic analysis method is a time history method. So first of all, let's discuss where and when to use these methods. So now in the IS 1893 code, it is clearly written about the use of these methods. So first of all, the equivalent static method. So as per clause 7.6, it is clearly written that this method shall be applicable for regular buildings with height less than 15 meters and in seismic zone 2. So for structures which is situated in zone 2 and the buildings having height less than 15 meters, the equivalent static method is applicable. So for all the structures which are situated in zone 3, 4 and 5, equivalent static method cannot be used. So let me show you that clause as well. So for all those structures except structures which are situated in zone 2 and height lower than 15 meter, we must go for the dynamic analysis method. So for example, in our case our structure is situated in zone 3, hence we cannot go for the equivalent static method, we must go for the dynamic analysis method. Similarly, in the dynamic analysis also we have linear and non-linear methods. So the linear dynamic analysis, which is the response spectrum analysis, can be performed up to around G+20 story building. This is based on the experience, and for structures more than G+20 story building you can go for the time history analysis method. Now let's discuss in detail about the equivalent static method. In our example, that is G+7 floors residential building, it is compulsory to perform the dynamic method, that is response spectrum analysis method. However, I will show you how to perform the equivalent static method. So in the equivalent static method we will calculate the base shear. So base shear is calculated as Ah times W. So here VB is the base design base shear. So what is the meaning of this base shear? Let me explain you with the help of a diagram. For example, this is your building and let's say this is your ground level. Obviously the structure will be fixed here at the base with the help of a foundation, and the earthquake loads, as you know, these are the lateral forces, so they will be acting in the horizontal direction like this. So let's say the lateral force acting on this structure at the top of the building is, for example, 20 kilonewton. So when the load of 20 kilonewton will act on this structure will offer a reaction of 20 kilonewton in the opposite direction at the base of the structure. Now what happens is that when you will increase this load gradually, let's say from 20 I will make this load as 30, so again the reaction at the base will be 30. However, up to a certain point, this base shear, this reaction at the base of the structure will not increase because there is certain capacity of this building. So the maximum reaction that this base will offer is what we call as the design base shear. So now in this formula, W is the seismic weight of the structure. So what is the meaning of seismic weight is that, for example, if this is your building, and let's say there are different floors in the building like this. So what happens is that, for example, if you consider this floor, then on this floor there will be beams and columns, and there will be dead load and live load as well. Similarly, on each and every floor there will be dead load and live load. So whenever you and on each floor there will be some weight, that is including dead load and live load. So this floor has some weight, and this floor had some weight, and this floor has some weight. So if you sum up all the weights, then you will get the seismic weight of whole structure. However, the IS code suggests that we will not consider full live load. So as per the IS code, we will, in the seismic weight, we will consider full dead load, that is 100% of the dead load. However, we will not consider the full live load of the structure. So if your live load is less than 3 kilonewton per meter square, then we will consider only 25% of the live load. However, if your live load is more than 3 kilonewton per meter square, then we will consider 50% of the live load. So let me show you this clause in our IS code. So it is given in table 10, percentage of imposed load to be considered in the calculation of seismic weight. So for live loads up to and including 3 kilonewton per meter square, we will consider only 25% of the live load, and for live loads above 3 kilonewton per meter square, we will consider 50% of the live loads. So basically the code is assuming some reduction in the live load, and this is true because we, in our case, for example, in our building we have considered a live load of 2 kilonewton per meter square. So the 2 kilonewton per meter square means 200 kg per meter square. So that is very high amount of load that is on every 1 meter by 1 meter we are assuming 200 kgs. And what the code is assuming that during earthquake, obviously 200 kg on every 1 meter by 1 meter will not be acting. That is, for example, in the building when some party is going on, then on every 1 meter by 1 meter 200 kg of load, and at the same time also earthquake is also occurring. So that is not possible in the real case. There is very less probability of that. Hence the code is permitting some reduction in the live load. Now AH here is the horizontal acceleration coefficient, and the formula for that is given by Z by 2 times of I by R times of SA by G, where Z is the zone factor, I is the importance factor of the building, and R is the response reduction factor. And as you might know that the India is divided into 4 zones, that is zone 2, 3, 4 and 5. So based on the severity of the earthquake zone, we have a factor that is called as the zone factor. So the values of zone factor are given in this table 3. So if your structure is situated in zone 2, then you will take a zone factor of 0.10. Similarly, for zone 3 it is 0.16, and the zone factor is highest for zone 5, which is 0.36. Now coming to the importance factor, it is given in table 8. So for important service and community buildings or structures like critical governance buildings, schools, emergency buildings like hospital buildings, telephone exchange buildings, television station buildings, etc., etc., for these important buildings we are considering an importance factor of 1.5. Next is that for the residential or commercial buildings other than those listed in serial number 1 and with occupancy of more than 200 persons, we will consider an importance factor of 1.2. And similarly all other buildings, for all other buildings we will consider an importance factor of 1. So for example, in our case, in our building, it is of G plus 7 floors. Obviously the residents are less than 200 persons, so we will consider it importance factor as 1. Now coming to the response reduction factor. So first of all, what is response reduction factor is that response reduction factor, along with the damping during extreme shaking and redundancy, influences the non-linear behavior of buildings, and during strong earthquake shaking accounts for inherent system ductility, redundancy and overstrength normally available in buildings. So basically why we are using the response reduction factor is that in our building we are providing the steel, and steel is a ductile material. So and obviously that will offer the ductility in the structure. So to account for this ductility we are using the response reduction factor, and also we are considering some factor of safety. Hence whatever the response that we are getting, like the base shear, deflection, etc., those response can be reduced, and that's why we are using the response reduction factor. So in order to reduce the response of our structure. Now the value of response reduction factor will depend on the system that we are using. So for example, for RC buildings with ordinary moment resisting frames, we are using a response reduction factor of 3. However, for special moment resisting frames we will use a response reduction factor of 5. So what is the meaning of ordinary moment resisting frame is that this frame will not be detailed as per the clauses given in IS 13920 code. However, if our structure is detailed as per the ductile detailing code of IS 13920, then that frame is called as the special moment resisting frame, that is SMRF. So since we are doing the ductile detailing, hence we are considering a higher response reduction factor, that is 5. So in our case we will use a response reduction factor of 5. And the last factor is the design acceleration coefficient SA by G. The value of SA by G is given as per clause 6.4. So based on the type of soil, that is whether the soil is medium, hard or soft, we have the values of SA by G, and also based on the value of time period. So what is the meaning of time period is that, for example, whenever a building is subjected to earthquake loads, that building will oscillate. So the time that is taken to complete one cycle of oscillation is called as a time period. And to calculate the time period, the code has suggested some formulas. So for the equivalent static method, the time period will be calculated as per clause 7.6.2. So for a buildings without any masonry infills, we will use these formulas. Similarly, for a building with RC structural walls, you can use these formulas. And for a building, for all other buildings, we will use this formula. So if your building is having internal partition walls and everything, then we will use this formula. So for our example, we will consider the formula as 0.09 h divided by square root of d. And for buildings which is having shear walls, that is also called as RC structural walls, we will use this formula. Here in this formula, what is h and d is that h is the total height of the building in meters and d is the base dimension of the building at plinth level along the considered direction of earthquake shaking. So what is the meaning of that? This is that, for example, if this is your building and let's say the earthquake is from the coming from the positive x direction, so what will take the value of d is this dimension of the building. Similarly, if the earthquake is coming from this direction, then we will consider the value of d as this dimension of the building. Now let's apply earthquake load in Etabs. So go to define menu and then click on load patterns option. So first of all, define the earthquake load EQX plus. The type of load will be seismic, and in the auto lateral load option, select the code for seismic, that is IS1893, and click on add new load. Let's define the earthquake load in other direction as well. So type EQY plus. Again the type of load will be seismic and the code will be same, that is IS1893. Click on add new load. Now select EQX plus and click on modify lateral load option. In direction and eccentricity, uncheck all the y direction since we are applying the earthquake load in x direction, and also uncheck the eccentricity as well. Coming to the story range, top story will be story 10 and the bottom story will be story 1, that is above ground level. The response reduction factor will be 5 for special movement resisting frames. Zone factor, as we have discussed, it is 0.16. Site type will be type 2, that is medium soil. Importance factor is 1 since our building is a residential building which falls under the general category. And coming to the time period, you can select your program calculated, or you can also have a user defined time period. So here you need to calculate the value of the time period manually. So if we see our building, then to calculate the time period as per the code, IS1893 has given the formula as 0.09 h upon square root of d. So here h is the height of the building above ground level. So in our case it is 26.365 meters, and d is the dimension that is considered in that direction. So in x it will be x direction, in y it will be y direction. So based on this, you can also input the time period manually as well. So as of now, let's keep it as program calculated. So keep it as program calculated and click on OK. Now select EQY plus and again click on modify lateral load. This time we will be unchecking all the x direction eccentricity, and also we will untick the y direction eccentricity since we are not checking the eccentricity. The top story will be again story 10 and bottom story will be story 1. Response reduction factor will be 5. Zone factor will be 0.16. Site type is type 2 and importance factor is 1. And again the time period is program calculated. Click on OK and again click on OK. So guys, this is how we will be defining the earthquake load in Etabs. If you like this content, please do subscribe to my channel and also share it with your friends so all the students can get the most benefit out of this. Thanks for watching. Bye for now.